Good afternoon and welcome to our fourth in a series of webinars on LoRaWAN Wireless. Today we're proud to present the webinar entitled Why Wireless is the Best Upgrade for Dust Collection Systems. My name is Heath Jenkins and I am in product management at Sensicon. And today's webinar is focused on owners, engineers, maintenance folks, environmental health and safety, at both end users and OEMs that are interested in either replacing existing sensors, maybe adding capabilities and adding sensor types to the existing dust collector, or for OEMs that are looking to offer something a little bit different to differentiate themselves from their competition. We will be taking questions. If you look at the top bar, you can see a Q&A button. Please put your questions there. And at the end of the webinar, we will answer those. We are recording and we will be posting the webinar, if not later today, definitely by lunchtime, by noon here on the East Coast in the United States tomorrow. So without further ado, let's jump into the agenda. Today, we're going to talk about dust collector systems and provide an overview of what specifically we're talking about to get level set with that. We'll talk about the variables traditionally monitored in dust collection, the direct costs of wired sensing systems, and then migrate into LoRaWAN Wireless, what it is and how it works, and a little bit about installation. Use cases and a recent example installation that we had here at Sensicon that's of interest to dust collection folks. And then wireless monitoring benefits by discipline, for example, in EHS, in operations, in purchasing. And then how to evaluate ROI. We've got a example of that, wired versus wireless. And then finally, how to upgrade to LoRaWAN. And spoiler alert, it's pretty simple. And then wrap up with key takeaways and Q&A. So without further ado, let's just jump right in. Traditional dust collection systems, 90% of the market is covered by baghouse type, cartridge type, cyclones, and wet scrubbers. That's in North America, 90% plus of dust collection systems. And within those systems, there's a whole host of variables monitored. There's some that are standard and others that are a little above and beyond, maybe based on the type of the type of process that's being run in the plant and what sort of dust will be and particulates will be filtered out. So we've got differential pressure, very common one, and that can be done with either a gauge or a transmitter or even a pressure switch. Airflow rate, typically via pitot tubes. Temperature, drum level for indicating when the drum is full and needs to be emptied below the dust collector. Inlet and outlet pressures, particulate concentration, liquid flow rate, particularly in wet scrubbers, to ensure that the flow rate matches the gas rate and you get the right amount of liquid entrained into the flowing gas. pH level, that's a little bit specialty. And then electrical current, that can be used as a predictive maintenance heads up, particularly on the fans. And all of these combined serve three general purposes. One of three or all three general purposes: safety, efficacy, how effective is the system, and how efficient is the system. So it's an important part. It's the brain, if you will, of the dust collection system. So we can all agree that more sensing is probably better in general. And traditionally, the installations have involved wires. But what are the cost categories associated with a wired system? I'm showing a few pictures there of traditional sensing elements. And over to the left, I just have some broad categories of direct cost for a wired system. First off, you have the installation and infrastructure costs, the cabling and the conduit and the site disruption during that process. We have maintenance and repair, including, and I hadn't really thought of this before I moved into wireless technology, but the troubleshooting of wired systems can actually be quite complex. If you've ever troubleshot something, a wired system, you know that digging into a bundle of wires to find the one that might be broken can sometimes be tough in a short run. And you add into that the long run, the long runs that you see in many plants, and it becomes even more onerous. So troubleshooting complexity is a big one. Upgrades, if you want to add a new sensor and you need to run an entire line just to get that sensor all the way through the plant, that's not a small deal. Operational downtime, and that includes repair-related interruptions and that limited flexibility that I mentioned earlier. Just that operational downtime can be significant if you're moving equipment, for example, to get to where you need to be. Integration and legacy issues. And what I really mean there is most folks have some sort of ERP or building management system, SCADA system that they want to integrate dust collection data into. And there are compatibility challenges there to get it onto that platform, those platforms. And that integration with already existing company systems can be quite difficult. But there is a better way, and that's why we're here. LoRa. So let's talk about LoRa and LoRaWAN and the differences between the two. LoRa was established in 2009 by a French company by the name of Cyclio. I'm sure I'm mispronouncing that, which developed chirp spread spectrum. That's the foundation of LoRa and LoRaWAN. And when you hear those two, LoRa and LoRaWAN, it's important to know in most cases you want to refer to LoRaWAN. LoRa is the physical protocol of the wireless transmission. And LoRaWAN is the framework established for interoperability. It is an open standard, so you have to make sure all the different devices, the different manufacturers play nice with each other. So what's so great about LoRaWAN? Well, it has robust interference resistance thanks to that chirp spread spectrum. And what that does is modulates the signal across a frequency bandwidth to ensure that transmission takes place regardless of noise or interference of any type, really. This provides a long range, up to 10 miles, you'll see publicized pretty widely. More realistically, in rural areas, you're talking about 5 miles plus. In suburban areas, 2 to 3 miles, and then maybe in urban areas, a mile or so. Any wireless system is going to be impacted by obstructions, whether it's drywall, concrete, trees, hills. There's always a price to pay for that. LoRaWAN is just willing to pay a higher price to get to that 10 mile or that multiple mile range. It does this with low power consumption. Most LoRaWAN sensors are battery powered and can last up to 10 years. Now, that's achieved both through the LoRa protocol, but also via the fact that LoRa sensors are interval based. So it's not a continuous transmission, and that's important to know. If you're looking for a continuous transmission, LoRa is a great technology, but it's probably not the right fit for your that specific application for you. The intervals, typically you see 10 minutes as a minimum interval, and you can set those anywhere above that in general. They're cost effective. LoRaWAN sensors, 90% are probably below $400. You do occasionally see something well above that in specialized applications with multiple environmental sensors. But for the most part, they're sub $400. They're scalable. One gateway can take thousands of sensors that are within that 1, 5, 6, 7 mile range. And it does that through that CSS, that chirp spread spectrum, and the fact that there are multiple channels. So it can take, the gateway can take quite a load of sensors. You don't need a bunch of gateways. And then strong security features. That's the cost of entry, right? That's really what it takes to get into the door. You better have security. And LoRaWAN has it with AES 128, which is bank level security. You can see the graphic on the right is actually where it's a visualization of where LoRa lies in the bandwidth versus range spectrum. And you can see it's very expansive as it relates to range, much longer range than Wi-Fi and even cellular. When it comes right down to it, the short ranges on cellular don't make a lot of sense. So it covers that entire place where LoRa makes sense both in those very short ranges, but also into some pretty extensive ranges that we've already touched on. And then you see a little picture of a LoRaWAN differential pressure transmitter that would be applicable in dust collection. So moving on, that's all well and good, but surely installation is difficult and complex, right? Nope. Really consists, a LoRaWAN network really consists of four major parts. The sensors, they can be collecting environmental, industrial, agricultural monitoring. There are over 40 variable types that I've seen. And so if you can think it and you want to measure it, LoRaWAN probably has the answer. Those LoRaWAN sensors transmit that long distance to a gateway where the LoRa signals are received, processing from multiple devices, and converts those LoRa packets into IP, Internet Protocol packets, and sends to number 3. But before we get to number 3, I got to add that that's called a backhaul. That sending from number 2 to number 3 is referred to in IT circles as the backhaul. That backhaul can be Wi-Fi, it can be Ethernet, or it could be cellular. And the gateway also adds some metadata, like the gateway ID, so the server knows which gateway it's coming from, the signal strength, which is very useful, especially in installation and troubleshooting, signal to noise ratio, for example, and a timestamp. That network server then is more or less the brains of the map of the system. It does the device registrations, make sure that it's authenticated, that those sensors belong to this network, they're not from some other network. It routes the packets, encrypts and decrypts that from that AES 128 that we talked about, and delivers data to the application server, number 4. That application server is where the rubber really meets the road. That's where data is aggregated for analysis and storage. And you can also configure your sensors via downlinks for to change the interval time, for example. So maybe you want to change it from 10 minutes, every 10 minutes, you want a signal to every 30 minutes or twice a day. Sky's the limit there as far as how long you can go. You can also set on this application, this platform, you can set notification thresholds. For example, if the differential pressure in my baghouse exceeds 18 inches of water column, I want to know. I want an alert. Something's not right. That's supposed to be pulsed, and you're supposed to see that decrease as it's being pulsed, and for some reason, it's not behaving as it should. That's just one example. There's all sorts of kind of neat notifications that you can provide, including low battery, so you don't have to worry about them running out of battery without being apprised of that in advance. So let's look at some use cases. So why you might want to integrate LoRaWAN into a dust collection system will vary. Many cases, it'll be a retrofit. Maybe you're missing basic measurements like differential pressure or airflow, or even the fan amperage. Maybe you want to add that or update. Maybe you only have a gauge and want to move into something a little bit more transparent that gives you better visibility to the dust collector. Maybe you want to add advanced measurements like temperature or humidity, spark detection, particulate sensing. Maybe that didn't come with the dust collector. This is a great opportunity to put it in effectively and easily. You might also retrofit purely in response to new or expanded regulations around your operations and specifically your dust collector. I have a case study there. This was very recent. We had a company in Oregon, a cement plant, that was being threatened with fines that would accrue daily because of a lack of differential pressure monitoring. And I should have put logging there because they were monitoring, but they were not logging. And the state had begun a new requirement to log differential pressure. So they needed a quick and affordable fix. They split it into 3 plant zones. It's a fairly large plant. They had 24 units total. And they wanted to monitor in those 3 different zones. So I only want these sensors monitored here, these sensors monitored here, and the rest over there. And that's very easy to do, setting up sub-sites within the plant so that the employees in zone 1 only see the sensors for zone 1, and so on and so forth. We experienced a 2 weeks from first contact to installation, and very pleased with the way that turned out. In the lower left, you can see an example of some of the finds. Just a quick Google search can yield these. Fines ranging from 42K to 152K in that bottom left, from a variety of industries, from cement to foundries to pallet manufacturers and everything in between. The lower right is it's a large find that I saw online that kind of blew my socks off because it was about a broken differential pressure gauge. Basically, a $50, $60 differential pressure gauge resulted in $325,000 in fines. There's some fine print there. I'm sure they would have gotten fined for the gauge no matter what, but they actually had falsified records. And so I think that's what hurt him more than anything. But it is a nice highlight of what can happen and the risk that businesses are exposed to if dust collection parameters aren't monitored correctly and up to date with state and local level regulations. So besides fines, what are the advantages of sensing in general and wireless sensors specifically? I've got a chart here. There's a lot going on. And don't forget, I'm going to post this in a webinar later, so don't worry, you'll be able to dive into it deeper. But if we focus just in the red areas where you have a high impact for sensing and particularly in wireless, for the DP column, the differential pressure column there to the left, you see that that's very helpful for environmental health and safety because it mitigates potential emission hazards by ensuring timely filter replacements. Moving to the right under particulate concentration, you see with a particulate sensor, concentration sensor, purchasing benefits by avoiding costly expedited filter ordering because trending is available on most LoRaWAN platforms. I haven't seen one where it's not available, but I'm going to say most. It's probably all. So you can see it keeps historical records, typically for years, and you can trend your filters and get ahead of filter replacement at what differential pressure and other variables, in this case, particular concentration, you need to start becoming concerned about a failing filter that needs to be replaced. And then operations benefits as well at the bottom of that column by detection of cleaning failures before they become a major issue. And for hopper obstruction, everyone enjoys that. Everyone has a high impact, including EHS with those reduced exposure hazards again, purchasing with cleanup avoidance because a hopper obstruction is no small deal. It's going to make a mess if it runs too long. And then operations with downtime minimization. You shut down that dust collector to take care of a hopper obstruction. That's going to probably cost you some production time. So those are just the big ones, but they are big. They have the potential to be a major pain in the neck. So let's look at a wired versus wireless comparison. We've established that sensing in general is important, but now you come to the point where you have to decide whether it's going to be wired or wireless. Part of that comes down to financials. So let's look at the ROI line by line for some major categories of cost. Hardware. So that initial cost, let's just use 10 NEMA 4X weatherproof differential pressure transmitters. Just doing a search and using a rough average for the wired solution, I came up with $4,000. The wireless solution was at about $3,000. Now, we can bite around the edges of that, but generally speaking, the hardware cost is going to be about the same. It's more or less a wash. The installation labor, that's a big difference. That is a huge difference. With wireless, you're looking at a 90% drop in installation. And to be a little bit specific in why that is, it's really just the mounting of the sensor itself, which shouldn't take more than 30 minutes, I would think. There's no running of wires. There's no conduit. There's no moving equipment out of the way to get to where you need to be. There's no employee on a ladder potentially falling off, if you're running over some beams, some I-beams. So installation is a major advantage. Cabling conduit doesn't exist in a wireless system. Roughly $2,500, depends on the run. A lot of variables there. Just had to pick a number, and $2,500 seemed about right. Infrastructure, you have to, no matter whether it's a wired solution or a wireless solution, you need a central hub to collect the data. So I just used a Modbus, simple Modbus concentrator that runs about $500 and compared it to a LoRaWAN gateway, which again, $500 is not an unusual price point for a LoRaWAN gateway, particularly an indoor gateway, which these can be and most often are. Annual maintenance / subscription. Now, keep in mind, this is a 5-year. And I wanted to be fair to both the wired solution and the wireless solution. And to be fair, I had to compare the wired solution and ensure that it had graphic capabilities, the ability to produce graphs of historical data, store that data, and trend it. So LabVIEW, which is a popular program out there, the full version was $8,300 over 5 years. The wireless solution not only stores that data just as a matter of course, it's inherent in it in the platform, but the trending is also comes standard. That also comes standard. So a big difference there in annual maintenance. I put battery replacement just because I thought maybe folks would be like, hey, wait a second, what about the batteries? Most sensors run on very commonly used batteries. You're going to replace them once in 5 years, let's say. Let's just go with maybe a worst case scenario there. And every sensor is going to cost you $10. I can speak for ours. We use CR123 batteries, very commonly available basically at any major store that you go to. So you summarize all that and you get a 50% savings over that 5-year span from $13,500 to $6,400. So a significant and difference-making, needle-moving difference. But then you add on the intangibles, just the faster deployment. Forget about the costs and the interruption in wiring a system. It's just now you've got to plan it out. You've got to have the personnel available. You've got a bunch of things to plan around, which extends the practical time that it takes to deploy. With wireless, it's as simple as receiving the sensors, mounting them where you want to mount them, where you're probably close to where you're measuring, because the sensor does need to be close to that, and pulling the battery tabs. The batteries typically come with the sensors. So pulling the battery tabs, sensors installed, and the platform's going to be a breeze as well, but we don't have time to dive into what the platform takes in depth. I do touch on that in a second. Improve safety through no exposed cables. Remote monitoring, and I know you're thinking, of course, it's remote monitoring, but I mean remote monitoring. Anywhere in the world, anytime. And the same goes for those notifications. If you're traveling and you're the head of operations, you might want to know if your dust collector went down. And this is the system that would do that for you. So not only can you view the graphs from anywhere in the world, but of course, those notifications via email or text will reach you as well. And then scalability, finally on the intangible scalability. If you want to add an additional wired sensor, you're probably still looking at about 70% of the cost to install one that you would for 4. I mean, because once you're up there running one wire, anybody who's done this knows that you could run 2, 3, 4, and it doesn't matter. You're just up there. So running one additional sensor with a wired solution is significantly more expensive than just adding on a new wireless sensor. So scalability is a big deal, future-proofing, those sorts of things. So how does one go about installing? So I have a graphic here of the range, and the range compared to Bluetooth, Wi-Fi, Zigbee, something commonly used out there in industrial wireless applications. LoRa, night and day, leaves them in the rearview mirror. I estimate at least a 10x range compared to the next largest commonly used one is Zigbee. So how do you install this? You find out the number and location and type of sensors and where you'd want the gateway. You just have to know that the gateway needs to be within range of those sensors. And you're going to find out whether it's in range really quickly, because you're going to have a received signal strength indication. And that needs to be more positive, the higher number, which in this case would be, negative 110 is higher than negative 100 is higher than negative 110. So it just needs to be a higher number than 110 in general to avoid packet loss and interference. You can access calculators online. In fact, we're about ready to release one that's very helpful, going to be very helpful for our customers. And they'll allow you to put the distances that you're looking at, as well as the obstacles that you expect. Okay, I've got a couple dry walls, I've got a concrete wall. I'm going outside and I've got a batch of trees between me and the gateway, or the sensor and the gateway. So that's going to help out a lot for any planning. And then, but for most instances, most plants, it's not going to be an issue. And then minimize any major obstructions. Huge steel sheets are tough on any wireless sensor. So you could try it, but if you can minimize that by going up a floor level, height is wireless best friend. So if that helps you avoid obstructions, that's sometimes worthwhile. Number two, you ready the platform. You just add the users, and you can put it into a hierarchy. This user is an admin and has full access to change devices and names and all sorts of things, and add other users. Or this user is just read only. He can monitor, get alerts, those sorts of things. And then finally, installation. I've mentioned it, and it is I'm probably mentioned it too many times, but the installation of those sensors is very easy. No wires required. In the gateway, finally, the gateway, those can be pre-provisioned. I know we pre-provision our gateways so that they know to accept the sensors that you buy from us. And then if you bought an extra one, we give you clear. It's not a difficult process, but it just takes get into the gateway, which has a very user-friendly interface, and adding the device ID number. So it's not difficult, but just know it comes pre-provisioned from us when you do buy it, and some other manufacturers do that as well. So let's summarize some key takeaways. We have some significant cost savings, eliminating expensive cabling and reducing installation labor and ongoing maintenance costs, which presents a strong lower total cost of ownership than ROI and long-term savings. You can scale these systems easily, and add sensors without any kind of additional infrastructure cost. You could deploy quickly without disrupting operations and leading to a faster project completion and realization of the benefits that come with that additional sensor that you put in. Comprehensive monitoring capabilities. There's not much you can't monitor with wireless generally, and LoRaWAN specifically. Differential pressure, temperature, particulate levels, you name it. Enhanced operational insights through that remote access and real-time data allows you to be proactive in your maintenance and efficiency improvements. Improve safety and reliability. You reduce those hazards from exposed cables. Proven real-world results. It's been around for 10 years now, and case studies such as the Oregon cement plant show how fast implementation and measurable improvements can occur. And then getting to the end here, sustainability and energy efficient. This helps optimize system performance, which in turn reduces energy use. So you're going to see an operational benefit every single month that you're using some of the more advanced sensors to help dial in your dust collector. And then future-proof. You're future-proofing for regulatory compliance, and you're going to adapt easily to evolving operational needs. So with that, let's talk questions. Let's see what we've got. Okay, so I've got a couple questions here. Question number one, what are the typical costs for the entire system outside of labor? Good question. Let me break it down by that 4 points that I had the map for. So you have the sensors, which run $100 to $500, depending on the manufacturer, depending on the type of variable. Those are the main things that impact price. So if you want to put the worst case in your head, $500. Gateways, $300 to $5,000. You're talking utilities might use the $5,000. For most, you're going to land in that $500 range. So we're going to use $500 for that. So we're up to $1,000. And then subscriptions. And again, this varies by manufacturer, by the platform provider. But in general, you're going to pay $5 to $50, maybe $75 per sensor. So if you have 10 sensors, let's say that's $750 per year. So we've got $1,700 the first year and $750 for the following years. For what really is a system and a technology that adds quite a bit of value. All right, question number 2. Can LoRaWAN be integrated with existing monitoring platforms and systems? Yes. The good news on that is that external platforms can be integrated using the LoRaWAN application server. That was number 3 in that map that I showed. That acts as that acts as middleware with APIs that you can use for an existing ERP, for example, or MQTT for building management systems or SCADA systems. So it's been done. It's not extremely difficult, but it's a little bit more involved than using the manufacturers or a third-party platform that's purpose-built for LoRaWAN. But just know that it is very, very possible to do that. Looks like that's all the question. If there's no other questions, I'd like to thank you all for attending and invite you to connect with us here at Sensicon if you have any questions. And I also wanted to let you know to keep an eye out for our next webinar on March 26th, when we'll be talking about the use of LoRaWAN with BACnet. So it should be pretty fun, should be pretty exciting, and really expand the use cases for LoRaWAN in general. Thank you, everyone. Have a great day.